Good morning, my dear friends. Today we are discussing a very important topic for the examination point of view as well as in the science graduation point of view. The motion of a rocket. The topic is motion of a rocket, which is a very important topic. Let me make you clear, my dear friends, that whenever there is a saying in English, and especially in educated saying, I can say that maybe common people may not understand that, but actually there is a saying, famous saying in English. Whenever a difficult subject or a difficult thing is explaining to the people, they used to say that I am not explaining you the rocket science. This is a small thing, but actually they are explaining toughest things. That means the rocket science is very tough thing. But comparing very comparing to any other toughest things. So that is the difficulty of the rocket science. We are not detailedly studying about rocket launching and anything. In fact, there are so many engineering as well as research things are involved. But the basic physics principle behind the rocket motion, we are going to study. So that is because the rocket technology is such a uh, huge thing and very difficult task. Very few countries are sending the rockets. So, like European Space Agency, NASA, and ISRO, along with the French and China and Japan. Very few. Of course, Elon Musk is an entrepreneur and he is the successful man behind the private launching of the rockets. Okay, let us uh, understand the rocket science. See, the rocket is an example of the system of variable mass. So, so that means in the previous section we discussed about the variable mass system. That means with the time, mass is also changing. Mass of the system is also changing. So the rocket consists of a combustion chamber. It consists of the combustion chamber in which the liquid or the solid fuel is burnt. Fuel can be liquid or a solid. So, just for the sake of normal understanding, coal is a solid fuel, whereas petrol is a liquid fuel. Like that, the paraffin-like things are also rocket liquid, liquid and solid fuel. Both can be used in particular rockets. So they see why oxidizer is required. We know that the burning requires oxygen. Actually, frankly speaking, if we don't have oxygen, still burning is possible. The chemical reaction happens in burning is called oxidation. Oxidation. So oxygen is not just only the oxidizer. There are other chemicals which are more powerful oxidizers. So oxidizer, because normally oxygen is a natural oxidizer. If we don't have oxygen or the oxidizer, burning is not possible. If there is no burning, no combustion, and no jet is coming out in rocket motion, actually burning of the fuel and ejecting of the fuel is the action. Rocket moving forward is the reaction. It is not, please remember this, my dear friends. Most important thing, many of the students may not understand this. Rocket movement is not action, it is the jet coming away from the rocket is there. So if even if you see this one, see this fire like of jet is coming out, coming this direction, right? So this is actually action, my dear friends. This is action, this is reaction. Rocket movement is reaction, this is reaction. Okay, so that is an important thing, one should understand that. So if there is no, if if there is no combustion, if combustion is not there, rocket will not move. So combustion is very important thing. So how it is possible, to for the combustion and ejecting of the jet, what is required? Oxidizer is required. So oxygen working as a natural oxidizer is not available at higher altitudes, interstellar space. So obviously we don't have any other choice but to carry the oxidizer as well. If you put the petrol inside your bike or car, it takes oxygen from the outer atmosphere. Okay, outer atmosphere, from the outer atmosphere it takes oxygen, it burns. Internal combustion takes place, and your bike or car will move. So if there is no oxygen is not present in the environment or the atmosphere, your bike or car will not move at all. So that is the most important thing one should understand. That is the reason why, my dear friends, at Everest, at higher altitudes, that is nearly 8.8 kilometers height elevation, oxygen and even atmosphere is very rare. That is the reason why helicopters will not go, okay, at such a higher altitudes. So that is the thing. So oxygen is a very important thing for the combustion and everything. So oxidizer we are taking in the rockets. So and then oxygen or nitric acid is another oxidizer. Those separate chambers we are taking, and the combustion chamber. The later stage, the fuel gunpowder, which itself carries its own oxidizer from the single chamber, is injected in the combustion chamber. Okay, so this is a typical schematic diagram, my dear friends. This is where you can see the fuel cylinder. In that, fuel is there, and another one is the oxidizer cylinder. And from the oxidizer and the fuel, both are coming into the combustion chamber, where these two get mixed and burns. So this is the combustion chamber and the nozzle. So it get exhausted at a higher speeds. So the thrust, the thrust is coming out. So this is how the basic principle of the rocket is, working principle of the rocket is. So this is the schematic diagram, just for the sake of understanding. Frankly speaking, whenever we are talking about the rocket, it must be written in the upside down. Diagram must be upside down, but this is in lateral representation, horizontal representation. Please, in the examination, my dear friends, I suggest you to draw this diagram, this kind of diagram, in upright direction. So because normally even a small kid can know that it is the rocket which is moving upright, not in the horizontal motion. Of course, missiles or cruise missiles are modified. The rockets with the avionics, they are capable of moving in the horizontal direction as well. But the rocket is a rocket which is moving in the upright direction. So I advise you, my dear friends, please draw it in along the y-axis. Don't draw it in the x-axis as I show you, because in the landscape it is quite easy for you to see it. Okay, so that is the reason why I am put it. But in the portrait is the orientation of your examination paper. Please don't draw like this. Okay, so That's it. When the fuel is burned, the pressure inside the chamber rises very high, very, very high. Due to high pressure inside the combustion chamber, the gases are expelled from the tail of the rocket. The expelled gases are in the form of the jet with very high exhaust velocity. See, my dear friends, so even our Diwali rockets are there, small rockets. So, see, do this small experiment, my dear friends. You just make a hole inside that, or you loosen the packing of the rocket will not move. Why loosening of the packet makes rocket useless? Because unless and until the combustion chamber is tightly packed, and the jet is coming very fastly and effectively in one direction, in the opposite direction only, the rocket will move. So if it is having sufficient space to combustion and there is no expansion, so it will not come very fastly quickly, so that means rocket will not work. So thrust is most important. What we are making is generating the thrust at a higher amount, that makes the rocket to move at a higher velocity. So that is the basic principle. So consequently, the rocket rushes in the direction opposite to the direction of the escape of the gases. So this is the reaction, my dear friends. So everybody will say that rocket motion is now based on the Newton's third principle. No, what is Newton's third principle? Action equal to minus reaction. So don't explain in that as a kid is explaining in high school. Every reaction is associated with equal and opposite reaction. So full sentence you should use it. So the motion of the rocket can be explained on the basis of the Newton's third law of motion and the momentum principle. Let m be the mass of the rocket including fuel, and v its velocity at any instant of in laboratory frame of reference. Then let in a time interval dt an amount of mass dm is ejected from the rocket in the form of gas jet. Suppose minus u bar is the velocity of gas jet with respect to the rocket. See, my dear friends, as I told you, the jet is the action, but still we the human beings are very, very selfish. Whatever the result we are getting, that is the result only considered as the positive. What is our result? Is reaching the higher altitude. So that means that we are taking in the positive direction, even in our coordinate system also. Origin is like our laboratory. So if y-axis is showing you the height in the height, obviously along plus y-axis is taken, you should take it as positive. So the jet coming out is conventionally we should take it in minus sign. Minus u bar is velocity of the gas. So you see, my dear friends, I did not write it. Please don't forget to write u bar like this. So then the velocity of gas jet in the laboratory frame will be v bar minus u bar. Let v bar minus u bar is the v relative, that is the relative velocity. Okay. So the rate of change of momentum of jet issuing out of the rocket, that is force acting on the jet, rate of change of mass of the rocket due to escape of hot gases x velocity, so that equal to dm by dt equal to v bar minus u bar from the Newton's third law of motion. This is equal to the thrust on the rocket tending to move it in the forward direction. So thrust acting on the rocket to move it forward, T equal to dm by dt v bar minus u bar. External force by the external force acting on the rocket is F external equal to minus mg. We know that, my dear friends, m is the mass of the rocket and g is the gravitation acceleration due to gravity. So that is mg is the weight of the rocket. Then the force acting on the rocket in forward direction is F resultant equal to dm by dt to v bar minus u bar minus mg. We have to subtract that. that weight component. From the Newton's second law, the force on rocket is equal to d by dt of m into dv. My dear friends, in variable mass system, I told you that so you should not normally derivate it like that, so don't write dm by dt into v and plus m into dv by dt. Please don't do like that. Okay, so that d by dt of mv equal to dm by dt into v minus u minus mg, that equal to d by dt v into. So this is actually just for the sake of your understanding only, but we should not write like this, but v into dm by dt minus u into dm by dt minus mg, that equal to m into dv by dt equal to minus u into dm by dt minus mg. This is the first rocket equation. dv bar by dt equal to minus u into 1 by m into dm by dt minus g. So when you are asked to write the rocket equation, you should write up to this point. If you so consider the magnitude of v, u and z. We know that d p is equal to minus u into dm by m into g into dt. So dv equal to minus u into dm by m into minus g into t. Integrating equation 5 from the beginning of the motion t equal to 0, that is even you know that 5 4 3 2 1 0, like that the countdown will end, and once the countdown is end, count up down means up to 0. So from that is the time 0. So even if you watch the live telecast by the ISRO or the NASA, so it is the countdown exactly at the launching time, that is t equal to 0. Okay, so upon the arbitrary time t, we get integral v naught to v dv equal to minus u into integral m naught to m dm by m, that is minus g into integral 0 to t dt. Therefore v into from v naught to v, that equal to minus u into log natural m naught to m minus g into t 0 to t. V minus v naught equal to minus u into ln m by m naught minus gt. V equal to v naught plus u into ln m naught by m minus gt. Equation 5 represents the velocity v of the rocket at any instant t. This is second rocket equation. Special cases, if the force of gravity is ignored, then v equal to v naught plus u log m naught by m. We have studied about a rocket. The rocket depends upon the principle of jet propulsion. The principle of jet propulsion depends upon the law of conservation of momentum. According to the law of conservation of momentum, the jet emerging in the backward direction makes the rocket to move in the forward direction. Okay, this is most important question, my dear friends, for the examination point of view, and even for the science point of view, most important thing. So I'm just for the sake of the the general knowledge, I already told you list of the few are launching countries. Soviet Union is the first one. The first satellite is Sputnik 1, and second one is the United States, and France is the third one. Fourth one is the Japan, and the fifth one is China, and the sixth one is the UK. Sixth one is ESA. In fact, today it is the ESA taking care of the entire. And the next one is the India, and eighth one is the Israel, and Ukraine is also sending. So USSR, presently Russia, it is Russia. Iran is also capable of sending the rockets by own, and the North Korea recently is the player. Okay, so my dear friends, less than 10 countries are capable of this technology, such a huge technology. Even in fact, it is the during the Cold War, which makes India very difficult to acquire this technology. But great visionary of the then Prime Minister and the great visionaries of our scientists. They put India proudly on the map of the world, where the space technology were also the pioneers, and even not the NASA is able to send more than 100 satellites at a time in a single launch. It is none other than the India is capable of that. So we are very proud of that. So this is all for today. Thank you. Any questions, you may please leave